Again, we are live. It's day 5 of learning Linux. So, let's do something cool. We need LabX slash Linux Journey, the official doc for this 100 days challenge. And I got a streak, I guess. Uh, so, what are we gonna do? We finished this, and we were in process, right? And we also finished this in a way, but not that how will I say, but not that in depth. We did completed it, but I guess I skipped some of the concepts, so I will read it now. So we learned about this, right? So stat, uh, the current status of the process, right? So let me just open up my terminal and type ps. Okay, so when I type ps, I'm getting pid, tty, which is the terminal time, and cmd. So if I type ps aux, and now I will get everything. And now we are getting pid, cpu uses, memory uses, and okay, here are the status. So yesterday we learned about this status too, right? So let me see what this status means. As far as I remember, there were four status, but I see now currently I'm seeing some more. Okay, so there are total four state, right? Running, sleep, stop, and zombie. But I don't know about these. So let me like just copy this. I copied, and let's see over here. So these all are the processes that are running right now. Now let me go back over here. Let me open ChatGPT and enter the command and ask clarify all the classifications, right? So let's see what it says. Okay, so we know about user, owner of the process, Rudy and root, and PID CPU uses percentage currently shown 3.2. Okay, let's see which process is using the highest CPU. And I, I think we can use stop too, right? So let's use stop and see. Okay, um, CPU 13 is our Brave. So Brave is using the most amount of CPU, and then it's second, which is also Brave. So so these are like mini process, or the tree of Brave. And these I am not quite sure what are these. And runtime is 34. And okay, so it says another one VSG, virtual memory size in KB, RSS resident size with total address space reserved, actual RAM currently occupied. Okay, virtual memory size in KB, actual RAM, total address space reserved, and TTY terminal associated with process. And okay, so this means no terminal. And stat current process state, status flag, running, sleeping, zombie, etc. So stat means that, right? But if I go back, okay, so stat means these are the stat, but we have separate than those particular three ones. Am I sharing my screen? I am not sharing my screen, so that was the problem. What I will do is that I will only share my terminal, right? Okay, I just shared the terminal only. And now, okay, so you can see now stat, we are getting ss, ssi, So let me just copy this much, and sorry, we need to do CTRC. So okay, CTRL shift C. I believe I will do something like this. Okay, now it will copy, and let me just paste. Before pasting that, let me learn about this too. So start means time date process start. Okay, time total CPU time consumed since start. Okay, let's see about start. So my thing started at 10:12. It's 2:14. So it's been starting this much, and time 0:03 means and time total CPU time consumed since start. So 5 second command start gives RST. Okay, we have more. So running, sweeping, and uninterrupt usually IO wait, stop, trace, zombie, finish but parent not collected it, idle corner. So we did get what we want to ask. So we don't need this. BST right recommend common uses. Now okay we did get it. So it's AUX not hyphen AUX. So what is this one? So using PS EF command in Linux. Another extremely popular syntax in system B style. You will frequently see PSEF command used by system admin. This is a powerful way to get a full picture of everything running on your system. The PSEF Linux command provides a full listing of all processes. List every process on the system. F display a full format listing while includes detail like UID, PPID, C, and S time start time. So if I EF right, so PS and EF, we are we getting the same results or is it different? Okay, we are getting a lot, right? Okay, we are getting less. So UID, PID, PPID. So two. So I want to see about the command about the process brave, right? So if I want to do that, how will I do that? Let me, okay, my web browser is running and I wanna see tree-like structure of its sub-process. How? So if I type this and let's say PST command grep, okay, let me copy this, right? Enter. So we got a lot. So the first one is this, which is right now what we are running then, and this is so there are too many processes. And let's say PST process review all, so it's command argument, so PID grep A, so brave and 20 lines after it. Cleaner method find brave only. Let me copy this and try PST, right? So these are a lot of processes running. Okay, if multiple brave processes exist, behind the main process, let's see which one is the main process. Okay, sorry, status update. And this is the main process. Okay, so we don't need much now. Okay, we got this top is just the as top, right? So terminal devices versus pseudo terminals. Okay, let's see about this, right? A true terminal device is a native console that allows you to type command and see output directly. You can experience this by switching to a virtual console. On many systems, you can press CTRL ALT F1 to access TTY1. What was the full form? Teletype, right? Later was a story of physical device for interacting with the computer. In modern system, a TTY refers to the terminal that provides the standard input and output for the process. There are the main type of terminal you will encounter: terminal device and pseudo terminal device. A terminal device is a native console that allows you to type command and see output directly. You can experience this by switching to a virtual console on many system. You can press ctrl alt f1. Okay, if I want ctrl alt, I just got logged out. The exact key combination may vary. F1 to access TTY1 to access TTY1 in Ubuntu. What is the key shortcut? Okay, let's see. And it says CTR ALT F1. So I didn't get anything. So let me clear this first. Okay, CTRL ALT. So I don't know why. Whenever I use that command, my system just crash out. Okay, these are two, right? And now let's see. Okay, TT1. This doesn't do anything. I think I don't need to concern about this. But let's see the theory. Pseudo terminal. This is a classical terminal. To read the graphical station, you can type the exact key combination may vary. A pseudo terminal PTS, on the other hand, is what you commonly use. Okay, so this is our own, right? This is even a terminal within the window. If you check the PSN output or the shell, you will see TTY listed as PTS. Okay, the role of controlling terminal. The processes are bound to controlling terminal. This means the process's life cycle is tied to the terminal station that is started. For example, if you run a program like find in your terminal window and then close that window, the find process will also be terminated. Processes without a controlling terminal. Some processes known as daemon are designed to run in the background and manage system services. These processes often start when the system boots and stop only when it shuts down. To prevent them from being accidentally terminated, daemon are not attached to a controlling a terminal. When you learn how to use PS to examine these processes, you will see a question mark in the TTY column. This question mark signifies that the process does not have a controlling terminal and is running independently on any registration. So this means that if there is question mark, then it means that our process is not being attached to the terminal and it's a background process or also known as daemon. So is every daemon a background process? Let me ask this. Is every uh, background process DAEM, daemon? Daemon or daemon? No, not everyone is a daemon. A background process is any process running without occupying or a current terminal foreground. A daemon is a long-lived service process usually state okay, oh yeah, it is inside the boot, I guess. So example of background but not daemon, you launch a command with okay. First minute and resume. Okay. Technical clue. Okay, we can actually know with jobs control term. We need to also learn about job. So let's go to process detail now. Process detail. What is a Linux process? We know about Linux process and PS aux. Well, we know about aux. Linux is responsible for all the status of process with user process creation. A fork and exec model. Okay, let's learn about this, right? The primary mechanism for process creation in Linux involves an existing process cloning itself using the fork system call. The fork call create a nearly identical child process. This new child process receives its own unique process ID, while the original process becomes its parent identified by PID. After forking, the child process can either continue running the same program as its parents or more commonly use the execv uh, system call to load and run. Okay. Load and run a new program. The exe execv call effectively replaces the process memory space with that of the new program, allowing a different task to begin. This two-step fork exec model is a cornerstone of how you create a process in Linux. I didn't get about the execv, so I will run again. Then is it continue running the same one? Use the execute system call to load and run a new program. Execute call effectively replaces the process memory space with that of the new program, allowing a different task to begin. Okay, this two is okay. Now I get it. Observing parent style relationship. We can observe this parent style relationship using PSL. Long. Okay, let's write. Okay, so we will write PSL and we will get PEID too. Obviously, I won't get it. Okay, PID, it's that, and let's see if something is same. Okay, we there is same, right? Okay, so this is child and this is parent, and oh, so we just got the best PL. If I can do PSL, will that fourth one expire? I guess it expired, and this is the new one. If I do only PS, I don't want to do only PS. Okay, if I do just uh, cat etc and as right, and if I do again if I do PSL, so we get on PSL, not another command. Okay. The init process. Every process is a child of another. There must be an original ancestor. This is the init process. When the system boot, the kernel creates inits as the very first user space process, assigning it a PID of 1. The init process is the ultimate parent of all the processes and run with root privilege to manage the system. It cannot be terminated until the system shuts down and is responsible for spawning many of the services that keep the system running. Okay, so init is a first process that comes with booting, right? And now we have process termination. We know about process termination. Okay, but let's see. Once the process is created, how does it end? The termination of the process is a critical part of the process lifecycle, ensuring system resources are managed effectively. A process typically terminates by calling the exit system call. Okay, so we have different type of system calls, right? So we actually got exec v, we got fork system call. Let me just go back and see, right? Okay, exec v system call, right? Okay, types of system calls I want to write about that too. Mm, types of system calls, right? Okay, we have fork and exec v to clone a child process to replace with parent data or something like that, to replace parent data in child process with new one. I don't know why I'm writing this, but I usually like writing. Okay, then we have exit V, and that's just two, and then we have exit, right? Exit, exit termination. This action signal kernel that the process is finished, and its resource like memory and file descriptor can be reclaimed upon exiting the process provided by the termination process. Termination stated to the kernel with its integer value by convention or status of zero. Okay, signal as an error. However, calling exit doesn't immediately erase the process. The parent process must acknowledge its child termination by using wait system call. Wait process to end. Okay, and now wait system call this calls around parent to retrieve the child termination status. Child process has ended by parent. Okay, this was orphan process, right? Or from process. What happens if a parent process terminates before his child? The child process becomes an orphan since his original parent can no longer call wait. The kernel intervenes. The orphan process is immediately adopted by a special system process, typically init process ID1, which is considered as the ancestor of all process. The init process then assumes the role of the parent, periodically calling wait to collect the. Okay, so that is also cool. And zombie process is that process where the child process ends but is not being let out by the parent process, right? So zombie process of different scenario occurs when a child process terminates but its parent has not yet called wait. In this state, the child process a zombie process. The kernel releases most of the zombie resources, but it keeps an entry in the process table. The entry contains the process ID and the termination status, waiting for the parent to collect it. The zombie processes are already dead, so they don't consume CPU time. You cannot kill them with signals because they are not running. The process of this parent waiting, calling wait to clean up the zombie is called reaping. If the parent process never calls wait, is amount an equivalent of while a few are harmless. Okay, we get it. Now it's time for signal. So, so let's learn about signal. So, what are signal actually? Signal is a software interrupt sent to a process to notify that an important event has occurred. Understanding in a signal is a fundamental managing process system behavior effectively. The purpose of signals serve as a primary method of inter-process communication (IPC). They have many uses. User interaction: a user can type special terminal character like CTRL-C, SIGINT, and CTRL-Z signal TSTP to interrupt or suspend foreground processes. Okay, that is actually true. And kernel notification: the kernel can send signal to a process to notify it of hardware or software issues such as illegal memory access. Uh, Process management system administration and other processes use signal to manage the life cycle of other processes such as requesting termination or configuring reload. The signal life cycle. Okay, let's learn this. When an event generates a signal, it is first delivered to a target process. The signal remains in a pending state until the kernel runs the process. When the process is scheduled, the signal is delivered. However, processes have signal masks, which can be configured to block the delivery of a specific signal. While when a signal is delivered, the process can take one of the server action. Ignore the signal, cache the signal, the process execute custom function for the signal and to respond to the event. Perform the default action if not caught or ignored. The default action is taken for many signals. This means terminating the process. Um, block the signal. We can also block common signals. Sign up, hang up often used to tell Diamond to reload its configuration. Sync int CTRC to terminate. Sync 9 to kill. Sync 11 segmentation fall. Sync term termination kill. Kill stop. Okay, we don't need this, right? Okay, we know about kill. We know about niceness. It means the setting up priority. Azure. La. Okay, wait for a while. Okay, so we did learn about niceness, right? It's like setting up the priority, and we don't need this. And process state, we learned about process state. Okay, we let's learn. Okay, runnable interrupt sleep. This one is the most common process state in Linux. The process is waiting for an event to complete, such as user input, terminal, or a network packet is arrived. It is interruptible, meaning it can be woken up by signal. This process is also sleeping, but it's in a state where it cannot be interrupted. This is typically used for short period during IO operation where interruption the process could lead to a corrupted state if the process is a long time. with a hardware or a driver. A zombie process has finished execution, but it still has an entry to the process table. It is waiting for the parent's process to read its exit status. Okay, we know about zombie stopped. Also, we also know about stop proc file system, job control. Uh, okay, we need to actually type some commands for jobs because we didn't type any command yesterday. Now, mm, 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 stop pgrep find PID by name, kill jobs, right? Okay, listing background. Okay, let's talk about job. Okay, what are jobs? Okay, let me just do jobs. Nothing. Sleep 100 and enter. Now jobs we get one, and now sleep and next to five and do jobs. Alright, alright. Do sleep 10, 6, 7, 8, 9. Okay, the job is, oh, we need to use this and, right? And now if I do jobs, now it is running again. Yes, jobs. Okay, to jobs done. It says done. Again, if I do jobs, okay, that left. Okay, so this is how jobs work. Now, how will we kill a job? Plus symbol. Okay, let's. The output provides the job ID in the first column its status, and in the plus symbol indicate that the most recently started background job, while minus is in the most recent one. Most recently started background job. Second most. Okay, okay. Managing acting processes. Okay, we don't need this. This is too tough. For stopped. Now sleep 13 process is running in the background job. Okay, add means background job, right? Okay, if I do something like, okay, let me I'm gonna job. Okay, it has been completed. So sleep 100 again, and let's do end. Okay, now if I do something like this, okay, let me just do jobs again. Okay, it's running, and now if I do percentage one, enter, and now we are in background. So if I just do that and again run jobs, so it's terminated. And now mm, to bring terminating background process, I need to do kill. Okay, let's run one thing in sleep 100 and do and now if I do kill percentage one and do jobs again. Okay, terminated. Jobs, okay. So that was it about job and finished. Okay. So now we have completed process finally. Now let's go back. Okay. Let's learn about permission, and I would like to skip some of the permission thing that I actually learned previously, and let's learn here user group others, all user group. Okay, to add execute permission. Okay, we know about numeric are pretty good. Ownership permission sudo cs on wins my file. I think both, okay, like this we can change both, right? Okay, umax. Okay, every file that gets created comes with a default set of permission. If you ever want to change the default set of permission, you can do so with the umax command. This command uses the 3-bit permission set. Okay, we don't need it, just changes the permission. Okay, set uid. Okay, set UID. There are many cases in which normal user need elevated access to the stuff. The system administrator can't always be there to enter a root password. Even every time a user needs access to the protected file, so there are special file for permission bits to allow this behavior. The set user IDs as UID allows the user to run a program as the owner of the program file rather than themselves. Let's say I want to send the password pass. Okay, we changed. We got let's look at another permission set. Permission. This. Oh, wait a minute. There is a file owned by root. How is it possible that we were able to modify a file owned by root? Where are we modifying? We are not modifying, to be honest. And let's see. Okay, I auditor went there, and we got that. But most of it is modifying the. What is password command doing? It's modifying a couple of files, but most importantly, it's modifying the etc side of file. Let's to oh, wait a minute. The file is on my root. How is it possible that we are able to modify this? Let's look at another one. Let's modify. You notice a new permission bit here. Okay, we don't need this too. I think this is for group ID. I believe. Here's more the sticky bit. Processes permission. So there are just theory. And this too, and elastic template. A sticky bit is a permission setting that can be applied to all directory. When a directory has been sticky bit set, files within the directory can be only deleted or named by the file owner. The directory owner or the root user is particularly useful for shared directory where the multiple user needs to create as many. Okay, so I don't think this is also necessary. So yeah, this was actually it. Boom, boom, boom. Now we are at the final chapter of the Grasshopper, which is processes. And let's learn about them. A Linux system is composed of many software components such as web browser, text editor, and media player. These components are known as packages, and they are typically managed by a package manager which handles the installation, update, and removal of software. Understanding this process is a fundamental part of the best way to learn Linux. What are Linux packages? You might know software by names like Chrome or Firefox, but on a technical level, they are packages. A packages is essentially an archive of files, including the application executables, configuration file, and documentation, all bundled together. This organized structure simplifies software management. The software supply chain, the journey of a software package involves two key roles. Upstream providers, these are the developer who write the software, they compile the source code and create installation structure, release new version and updates. Package maintainer, when a new version is ready, upstream providers send it to package maintainer. These maintainer review, manage and distribute the software to end user in the form of package tailored for a specific Linux distro. A common package format. While you can install software directly from its source code using a package manager is far more common and efficient. It's one of the best way to launch Linux command for system admin. There are two predominant packages, Debian and Red Hat. Debian used by Debian and stereotypes such as Ubuntu and Linux Mint. Red Hat Package Manager RPM used by Red Hat Enterprise Linux, Fedora CentOS. Mastering the tools to managing this package is the best way to learn Linux command line and skill you constantly use. How do vast number of Linux packages available online make their way into our computer? While you could visit the download page for each piece of software, a much more efficient solution exists. Package repositories. What is a package repo? A package repo is a central storage location for software. This repo, hosted on a server across the internet, contain curated collection of Linux packages, eliminating the need for manual downloads and installation. This system is a cornerstone of modern Linux package management, providing a streamlined and secure way to manage software. How repo works? Your system package manager needs to know where to find this repo. You provide it with a source link and it handles the rest. For example, to install Docker, you don't download it directly from the website. Instead, you configure your package manager to use Docker's official repo, which is hosted in a URL like once configured, your system can access all the packages within the repo, such as Docker, CE, Docker CLI, container.io. Configuring repo sources. Your Linux distribution already comes with a set of pre-configured repo for all the base package on Debian based system like Ubuntu, the primary configured through the apt source list. This list is a single file. Your machine package manager is just to know which repository you check for available updates. It is also common practice to add new repository etc. So, write in your Ubuntu version you even use we don't need to learn about these tar and ggrip we learned about that and package but we need to see about this if there is something different. Okay, there is nothing different from that. Okay, okay. Say libraries rpm and tpkg. Although most of the courses is about package management system like development of package management for our province. Although very useful and reliable, they don't come with the suite pat mobile utility. Just like .exe is a single executable file, so is a DB in RPM. You normally wouldn't see this if you use package repo. But if you directly download packages, you will most likely get them in this powerful format. Obviously, they are exclusive on distro. To install these direct packages, you need to package manager command rpm dpkg. These tools are used to install packages Okay, so we have to install packages like the Debian dpkg, some dev packages are for remove. Okay, that is cool. Yum and apt. Okay, the primary difference between these two systems lies package management essential tools. Two of the most commonly package management are YAM and apt. APT advanced package root YAM package manager is RPM based. Okay, we don't need about RPM thing right now, so we can compile source code. Source code. Okay. You may find packages that are only with your source code. To use it, you need to compile and install it to your system. This lesson will guide you through the common process on how to compile your preparing your system. Before you compile anything, you need to necessarily only even machines like Ubuntu. You can install them with a single command. Build essential. Use the package installed to suit your solution, including GCC compiler and make utility which are essential for compilation. Dark after installing the tools, extract the content of the source code package using r.gd file, and, and before proceeding, always check for readme or install file. Install the directory. This file contains instruction. The standard build process. First run the check install. Then while different developer might use various build system like CMake, that most traditional method involves three-step process. Understanding this is fundamental to learn how to build source code. First, run the configured script. The script checks your system for all the necessary dependency. Tells the cells to execute the script from the current directory. If the script is implemented because continuing next run make command. This command reads file name make file in the directory and continue set of rules how to compile the source code into executable. Finally install. A better way to install should check install. Why should make install works? It has signal drawback. It doesn't. Drag a much better approach is check instead to install launch this installation process, but to copy file directly, it creates a native system like .deb. Okay, so that was it, and I think this much is for today. So today was very short, I know, but still